That is a fractal.
Oh.
And all kinds of weird. Look at the tunnel of infinity. Probably get started about 5 after. Let a few folks wondering. What do I do to my RailsSchool? Is the text size okay for y'all? Can you guys see okay? If it isn't, you can yell at me in the middle of class. Yeah. Better? Cool. What about that? Look okay? Probably be bigger too, huh? Shell. Reasonable. I'm not going to be doing much in the shell. Our noise bridge is getting more slick by the minute. We have, see the fancy lamps we have? Look at that. With these plants in the back. Cool. All right, why don't we get started? We're all kind of sitting here waiting to get going. So there might be people coming in. So I have a quick agenda on the whiteboard. And we'll just go through that, but we'll keep it pretty informal. So we'll do some quick intros. I want to talk about the goals of the class and RailsSchool and Noise Bridge and that kind of stuff. Then we'll talk a little bit about what fractals are, talk about the tools we'll use to draw them, and then we'll draw some fractals. And we'll see how long it takes us. Sound good? Cool. So I'll start. My name's Brad. I'm a web developer. I work at Koshek's Labs with Gabe and a lot of the other RailsSchool teachers. That's Gabe in the back. I'm a self-taught programmer. Just a few years ago, I was working for groups like the Sierra Club. I was an environmental kind of campaigner, policy guy. And that was fun. The programming is a lot more fun, and a lot more challenging, and very different. I'll probably mention this. One of the things that really inspired me was coming to RailsSchool and seeing that programmers weren't these like godlike people who just happen to know everything. That we mess stuff up all the time. I'm better at Googling than a lot of people, but that might be about it. And what I want to get out of the class is I want to solidify my knowledge of fractals, continue to learn more JavaScript, writing more, and I want to get better at that, and I want to have fun. And so if you guys that I'm not doing, please tell me. Cool. What can
my name is Superpowers. I'm about to start school, so I'm getting
And you said you were a mechanical engineer.
Yeah.
Cool. And is there anything in particular you want to get out of the class?
Let's see.
That's cool.
More JavaScript is good.
Yeah, how familiar are we? Actually, the one thing is like, how familiar are you guys with like JavaScript?
I'm doing front end class. So
Oh, cool. So yeah, yeah, awesome. Thanks, man. We start up front.
Yeah, sure. Well, my name's Devlin,
Cool.
and yeah, I've been programming for a while. Also, mostly web stuff. I started self-taught, like HTML, JavaScript, and little Perl and stuff. But I've been taking some classes here, and now that they do some online classes, taking some classes.
Yeah, cool.
And yeah, want to get out of the class. Maybe learn about fractals, but also pick up on some HTML5 canvas and drawing.
Cool.
And it's no E at the end of my name.
Yeah.
Thanks.
I'm not very good at spelling. So.
No.
I'm Kathleen. I have a little bit of programming experience in college. Studied mechanical engineering for that for a while, and for the last year or so, I've been doing UX design and sort of learning front-end stuff to be good at some random projects, and that's just kind of an interesting thing.
Awesome. You're the third mechanical engineer person I know who's into programming. Jacob's number 2.
I'm Lambert, and I'm also about to start boot camp. But I was a biochem major in college.
You were a what major?
I was a biochem. Biochem.
Oh, cool. Nice. Awesome.
And I just came in to check out this class because we've been here before, so I want to check it out.
Yeah, cool. Sweet. Awesome. We'll go in the back.
I'm Michael. I've been working in software for about 4 years now.
Uh-huh.
I'm a Sierra Club member. Yeah, I've been running at RailsSchool for a couple of years now. It's always fun for me to help. So, yeah.
Awesome. And you probably know JavaScript fairly well.
I do it's not my day-to-day language, but I go, okay.
Yeah, cool. We're just finishing up intros, so I'll put you in the spot. We'll do Gabe first.
My name's Gabe. I founded this school and love problems.
All right, you're up.
My name is Angel, like Angel.
Mm-hmm.
I've been here sometimes. I'm beginner with Fred. I feel more comfortable with JavaScript.
Cool. Awesome. And I think we might have people watching on the Hangout at home. The Hangout is recorded. So if you want to go back to look at this later, you can do that. But we also have people live. So if you guys are watching the whiteboard, and sometimes I'll have my screen full of like terminal, and I won't see people will put notes in. So if someone puts a note they can't hear or something like that because they're watching at home, please feel free to interrupt me. Cool. So so goals and housekeeping. So first, welcome to RailsSchool. Who here is the first time at RailsSchool? We have a couple of people. Awesome. Cool. RailsSchool is a free class started by Gabe about a couple years ago, and it's pretty informal and casual. Sustainability is a main goal. I've been teaching for about a year. Volunteer basis, of course, it's free. And we just like to have fun and hang out and talk about programming. And every single class I teach, I learn some stuff, and hopefully, students learn something too. So we're pretty informal. I usually start with a rough agenda of what I want to cover, but oftentimes skill levels are very different, and so we'll kind of maybe explore different things as we go along. So if you have questions or have an idea about something to explore, please let me know. And I might not always take you up on that suggestion, but often I will. So also, NoiseBridge does not charge us anything for this amazing, pretty nice space now with all this cool gear that someone bought and installed, which is great, and they're fundraising. You guys know rents in San Francisco are kind of high, and this is there's a library in the back. Consider making a donation. You can sign up monthly online if they accept Bitcoin. I'm pretty sure all kinds of cool stuff. And there's also yeah. So that's Tuesday night. So you can come back to our website, which I have open right here. A class a week or maybe two in advance, but we do one almost every single Tuesday. So you can check us out. You can sign up for emails and learn about the classes there, and we also email over the NoiseBridge listserv. So those are a couple of good ways to get in touch. And finally, if you would like to teach and think this is really cool, we're all volunteers, and it's pretty open. We've had some guest teachers cover topics. We have a rotating group of, maybe 6 or 7 teachers. And there's no criteria requirements. It took me a long time to feel like I knew enough to teach, and of course, I knew plenty by then. So I encourage you. Also, we have a satellite grant group in Charlottesville, North Carolina. So if you ever all are in Charlottesville and know people there, Virginia, thank you. And my geography in the East Coast not so great. I've never been there. You can go to RailsSchool there as well. So. Cool. So some of the goals I had for the class. So fractals are really cool, and if you kind of Google fractals, you see all these like trippy images and stuff like that. And I wanted to take a different approach than that and kind of start at the basics. And so one of the goals for myself and for the class is to kind of just get down to more basic HTML and JavaScript. We're not going to use any jQuery or any libraries. We're just going to actually write JavaScript code as a chance to learn a little bit more. And so one of the goals is to learn more about the canvas element. Remember how to write JavaScript without jQuery, and explore, and also learn about fractals and kind of stretch our minds a little bit. And finally, we can do this recursively, so we can learn about recursive functions, and that's always a really kind of handy thing to be able to do. So, any thoughts or concerns at this point? Cool. So who can tell me what are fractals?
You got asked that yesterday. I was talking about the class, and I wanted to say they were recursively defined self-similar shapes. I don't know.
Not bad. Yeah. Yeah. I don't think I would come up with anything nearly as precise. Cool. Yeah. Anyone else want to try another?
Like infinitely repeating visual patterns.
Yeah, that's usually how I think about it. And there's an element of scale, right? So usually they repeat smaller. But I don't know if that's necessarily part of what a fractal is. You can make them get bigger, I suppose. Most of the fractals we see, you know, there's a lot of kind of fractal-ish patterns in nature. Kind of things get smaller. Most of the interesting things you can do with fractals get smaller. Cool. Does that make sense? Everybody? Cool. Why do we care? Well, fractals are pretty cool. And you know, we care about them for a couple of reasons. One, learning how to draw them is kind of a fun exercise to figure out. And then second, you can use them in all kinds of interesting places, especially with graphics like video games. You use fractal design a lot. Anyone think of, has anyone actually used a fractal for anything other than like playing around? No? Okay, cool. Yeah, neither have I. But you can see how you might. I was maybe in mechanical engineering, some sort of fractal. Okay, well, so anyway, they are cool. I'm pretty sure if we had some game designers in the room, they probably would use fractals. I have a tree fractal that would be, you know, a good on video game kind of graphic. So I can imagine that maybe they use this. World, I don't know. So before we get started with drawing them programmatically, I wanted to draw them on the whiteboard, just so we can kind of get a sense of fractals. Did anyone like Google fractals before the class and look at cool stuff you can find online? Yeah. Well, someone got a book. So you can get really crazy with these things. You know, you can draw all kinds of cylindrical patterns and lines and all that kind of stuff. And, that stuff was kind of intimidating to me when I looked. I was like, oh my God, I'm going to figure out how to do this. When I volunteered to teach the class, I never drawn fractals. JavaScript is not my strongest language. I've never drawn anything on a canvas before. So I wanted to kind of start at the basics so I could figure out what a fractal was, and then give you a frame of reference to kind of understand these fancier ones, which I still don't really understand very well, but maybe when we get to the end of the class, we can pick apart some of the, like the Mandelbrot fractal code and see what's going on there. I thought, so there's on the top of the whiteboard, there's a link to GitHub where I have prepared, I did this ahead of time to make sure I can do it. We're going to do it from scratch here, so no cheating, but if you want to see where we're going to go, you can look at that. And there are 3 files in that. There's a rectangle fractal, a square fractal, and trees. So we'll start with the rectangle. So this is going to be our canvas, right? So what's the easiest fractal we can do with this?
With a tree?
That is not the easiest one, but it is an easier one.
Like Cantor's fractal seems one. It's like you take a line and you just remove the middle segment, and then you take another line and you split it into 3 and you remove the middle line.
Oh, cool. Okay, yeah, I haven't. Yeah, I didn't look into any of that classically defined fractals. I kind of just made my own. So we'll see what I did and compare it with other people doing too.
I heard of a triangle fractal. It's like you start with a triangle and then you have 3 here and then it goes on.
Oh yeah, like this guy, right? Like the,
yeah, exactly.
Like the triangle guy.
Yeah,
Something like that.
The triangles are the same.
Yeah,
Yeah, okay, cool. So it's like a triangle tunnel.
Yeah,
Oh, that's a
exactly.
cool one,
And
too.
I think it might be 3D too, even though it starts with just a 2D triangle.
No,
It's,
No, okay.
if you just draw like an upside down triangle inside of it.
Oh, okay.
So we get 4 triangles at least.
So a triangle, and then an upside down triangle,
Yeah.
and then like this. It flips the axis like that.
Yeah.
Awesome. So I think that this is definitely not the simplest one I can think of, but it's cool. And maybe we can make it work. What was the design we were talking about? You like split a line?
If you just take a line and then you like subdivide it into 3, which is just kind of, and then you erase it. I guess there's no reason you couldn't do it with any other number of segments, and then you do the same thing over and over for each remaining line segment.
Oh, cool. Yeah, that's pretty sweet. Yeah, awesome. That's a pretty simple one. Yeah, cool. Just to get, maybe we'll go there and we don't have to do the ones I made either. We can kind of make our own kind of collaborative and stuff. Cool. The simplest one that I know about is basically just drawing a line and then just kind of repeating that. So if you have an element, you can draw a line in the middle, and then you can kind of draw a line in the middle, right, and then draw a line in the middle. So let's do that. Let's start with the canvas, and then we can see what. Cool. So you guys can, this is probably a good one to code a lot. And there's no like Rails. So here I have rectangles 2. You can see the first rectangle code that I wrote in GitHub, and I might refer to it. So we'll just start here, and then I'm just opening in a browser, which I learned recently in some cases because the browsers do not render files like they do server. But for this, it works perfectly well. And the cool thing here is even though we have an HTML element, the browser is giving us a head and body because it's really smart. Sometimes it's fun just to kind of take a step back and play with this. You can just have an opening HTML element and it will close it for you because modern browsers are really cool like that. So inside of HTML, we're just going to make a canvas element, and canvas can get a height and a width. I believe. So refresh, and here we have a canvas. I guess it's supposed to have a closing tag, so let's make it proper.
There's supposed to be 2 S's in canvas?
No, there's not. Thank you. I always mess that up. Because I worked for political groups for so long, I can't think of canvas spelled the right way. Yeah, you know the door-to-door canvassing thing?
Right.
Yeah. So you don't need to close it. You can also define your own arbitrary elements. So you learn if you want to make a canvas with 2 S's. No, it wants to close it. Okay, cool. And we can learn a little bit about canvas. Canvas is a really kind of interesting element in that it comes with these JavaScript properties that it has that are kind of unique. And there's a ton of them. You guys can see there's all kinds of really cool things. We can play with some of these things. I have not really messed with a lot of these type of things, but the base that I used is essentially what you do. It has a concept of when you're writing this, the basic concept is you create a drawing using JavaScript by moving the cursor around in this coordinate system in the canvas. And I'm sure there's other ways to do it, but this is the way I started. And then you call a method here, stroke, which draws the path. So the basic thing is you clear the current path, which kind of exists in memory. You create a new path by doing line 2 or arc 2 or whatever you want, and then you call stroke, and that actually draws it. And it doesn't draw it until you call stroke, which is sort of odd and interesting. So that's kind of the basic the basic API. So it allows you to kind of, like, if you want to build something at once and just kind of display it on the page, you can do that. If you want to show it as you're drawing it, you'd have to call stroke a lot, I believe. And also you have to call, I thought there was a clear path. You have to call begin path as well every time, I think, after you call stroke. I'm not sure if it retains the current path, so we can play with this. As we go through, I'm going to glance at my code here, and so I think it wants to close this. And we're going to make a script. We're just going to do it right here. Because why not? Cool. So, so far, we haven't done anything. And the first thing I did, which I think is a good start, is we're just going to draw a border around the outside of the thing. And we have a new person. Can you introduce yourself? And can you tell us something about your background?
I actually learned coding through RailsSchool. And I guess no Rails pass.
And you were a former mechanical engineer as well, right? There's two more of y'all in here. Yeah. I don't know what is there, some sort of exodus from the business or something? None of our machines will work. We'll have great software. So the first thing is, let's draw a rectangle. Sound good for the border? Cool. So if we look at the there we go, rectangles. So we can create a rectangle, right? We have to do a little bit of work before we can do that, though, because what you actually do is you have to call a getContext method and give it a dimension parameter. And this gives you back an object on which you can call those. So I was a little bit incorrect. So you call getContext, it gives you a thing that then that's what you hang all these methods off of. So I'm gonna add an ID to this so that I can, and I'm just gonna start typing in JavaScript for now. Man, all night long, I'm sure. And I think actually I don't have to, I think I can call getCanvas. I think I when I refactored my code, I dropped the getCanvas. So I know I'm writing some maybe naive JavaScript here, but I'm kind of doing that on purpose. We can talk about how to make it a little bit better. So first of all, let's see if this just worked, right? Anyone have an idea? How can we see if it worked? I'll leave that code up there for a second. First, we could reload to see if anything blew up in the console. And it did, because it's not defined. Does anyone know what I did wrong? Yeah. I remember this.
Document.
Yeah, this caught me. I was like, JavaScript. Document. And of course, in JavaScript, as I'm learning, document refers to, I believe it refers to the DOM. Actually, is that a correct statement? Does anyone know?
Sounds right. I think
It's kind of precise, and so it might be, it seems like it should be right.
Or it's the whole thing, it's not just like the body, it's everything that's loaded in this, is, yes.
I think so. We also have Windows. So well, let's do something here. Let's so let's put them out in the console. And one of the cool things I'm learning is you can actually dump all kinds of weird things to JavaScript because it does not care what the type is, and it'll give you all kinds of funny things in the console to play with. So,
so I think that the window is the top level scope of the JavaScript context, and the document is essentially a representation of, it's like specialized to the browser. Because you can technically have a JavaScript context without a document. If you're running on a server or something.
makes sense to me. Looks like we have two things here, and there's all kinds of cool stuff on here. But this is a really nice debugging technique if you guys don't know it, to see what kinds of properties you can call on things. So let's see now. Cool. And then we can do a little console log CTX. We do have. Can you guys read that? Does that sort of make sense? Cool. So we appear to have our proper canvas thing. So look at the look here and figure out what we need to draw. Since we're drawing a rectangle, we can look at the rectangle method here. Okay, it has a nice cheat there. And then rectangle takes, as arguments, it takes x, y, height, and width. So, and it's just rect is the function, right? Anyone know what the x and the y should be? I guess, I mean, they could be a lot of different things. But let's put the x and the y in the top left corner because that just makes sense, right? Anyone want to guess what they should be? Okay.
0, 0.
0, 0. This I found confusing because I haven't messed with the coordinate grid like this since math in college, and the top left of a is definitely not 0, 0. I think it was 0, 0 is the origin point. So.
But on the web, it's always kind of in whatever we have left or top properties, 0, 0 is always.
Yeah, totally. Yeah. And the height and width are 800 because that's how I made the canvas. You could actually draw a rectangle that goes outside the canvas. I don't know why you'd want to do that because you can't see it, but you can. So we have a rectangle, and then we can just call stroke on it on the context object that contains the path that we just defined with the rectangle function. I think. Let's see if it works. Wow. And we have a rectangle. Is it actually a rectangle? Yep, it is.
It's square.
Squares are a subset of rectangles, right? Aha. So I was trying to be abstract. Cool, everyone with me so far? That's good. So now that we've kind of drawn the border, let's draw some lines in the middle. And we have to kind of think about how we'd want to do this, right? How do we want to handle kind of drawing infinite lines in half the space of the surrounding thing? Anyone guess? I said it earlier, so it's not really. How should I think it's sort of a design question. Now, you know, what do we do next, right? We've got our rectangle, but we'll draw a line down the middle of this rectangle to make another smaller rectangle. And we want to draw a line through the middle of that rectangle and do that a lot. Right. So this was just kind of some toy code to kind of get our feet wet and comfortable with the thing, kind of draw a box around so we can see what the canvas looks like. But now we actually got to draw the fractal. So any thoughts? I mean, we could just kind of, I can, you know, kind of write some procedural code here and just kind of like do it.
Find all the X positions, have lines and draw them all, or you draw them all one at a time.
Yeah, totally. I never thought about that.
Divide up until you get to something less than 1 pixel width, and then you stop.
Yeah, cool. Yeah, we could do that. We could totally find like the what is it? The X coordinates of the top, right? And just get an array of like X coordinates that match where we want to draw the fractals and draw them all. That would totally work. I didn't do that, but that's totally cool. Anyone think of another way? Cool. The way I did these was a recursive function, right? And the cool thing about a recursive function is you don't have to kind of find all these X's ahead of time. Who's familiar with recursive functions? Okay, cool. I was not. I'd done a fair amount of like Rails programming before anyone ever made me write a recursive function. And the first time it was a humbling experience because I didn't know what it was, but they're really easy, but they're really, really powerful. And this is a really kind of a cool thing to know. Recursive functions are used all over the place in programming. You know, you can imagine, you know, in Ruby, so you have a hash, a nested hash. A hash has lots of other hashes, right? And you can call like hash.flatten and it like magically like flattens it out, even though the hash can have like 3 nested levels or 24, right? And that's the magic of recursion, just like recursing through that function, doing one thing at a time and continuing to do that until it hits some breakpoint. I think the technical definition of a recursive function is a function that calls itself. Right? So all we really need to do is define a function that draws our main rectangle, right? And then call itself again until we hit some sort of breakpoint. Or we could keep doing it forever and blow up the browser, which I've been doing a fair amount by accident. So let's define a function, draw fractal, and just to kind of have a shell here. So let's see what we're going to use in our API here to draw. And I think I used there's 2 functions, move to and line to, right? And the reason you have to do that is line to kind of has a weird thing where line to takes the current like cursor position, I kind of think of it, in the path, and draws a line to XY coordinates that you specify. So you actually have to move the cursor to one end of the line and then call it. You know what I mean? It'd kind of be cool if we could give line to like 2 sets of coordinate pairs and it would just draw a line instead of moving the cursor around, but this is what this works. So, make sense? So also we have to, the first thing we should probably do is we should probably call begin path on the CTX thing to clear out the path. Otherwise, this rectangle we drew is still going to be in the CTX object as a path. And we draw it a bunch of times, which makes the line thicker every time, oddly. So we can clear the path that way. And then the first thing is we need to move to somewhere. And we want to move to half of the X coordinate. Does that sound right? We want to, or we can move to the bottom too. What do you guys think? How do you want to do it? Top or bottom? Doesn't really matter.
Top is easy.
Yeah, let's do that.
That's the 0x, the 0y.
Yeah, totally. Yeah. So to move to this, we need to tell our function how big the top is because we need to move to half of it, right? So we know that the second argument to move to is going to be 0. That's the y coordinate, right? To take them in order, it does. So that makes sense. But we need to know how to get x. And so we can give our fractal function a parameter. Yeah, call it width. Sounds good to me. And then we can just do width divided by 2. And this is probably going to be fine, right? And that should move us over there. And then we need to call line 2. Whoops, CTX line 2. And line 2 has some parameters. So what do we want to give the x and the y for line 2? Remember, we're at the top, and we need to draw a line down to the bottom.
Oh, so it's always the same width over 2 to 800 because the canvas is 800 height.
Yeah, I think so. Anyone want to contest that? I think you're right. And do this weird little thing here, and
Next question, why are you doing with this variable just putting 800?
good question. I shouldn't be. I mean, I don't know. What I mean. Oh yeah, no. It like I was thinking about this. So the reason I'm doing it right now is because I always know because I don't need to modify 800 for now. And I think as we recurse through, we won't have to modify 800, but we'll see. We might have to go back and modify this function to change the y variable to be something we passed in. And when I was doing this, and I thought the way I teach it is to sort of do it like step at a time and go back and modify the function. So we could write this really interesting, right? We could define a height and width variable and like make the canvas dynamically so you could just change the height and the width, and that would be the way you would write it if you were doing this for real. Because right now it's like if the users were like, your canvas is awesome, but can you make it 700? You know, it'd be like, oh, damn it, that'd be really bad. So I guess you caught me being kind of lazy. Depending on where we want to go with the class, there's a bunch of really bad habits. I'd like to at least mention why they're bad. And I thought I'd leave them there for us to kind of clean up as sort of a learning experience about how to write safer JavaScript. And that's one of them. So far, so good. Anyone try this? Did it work?
No error.
No errors, and it's not working.
Because we didn't call that function.
That's right. I got hung up on that once in my life, and I don't think I'll ever get hung up on it again. How should we call the function?
Just draw fractal and pass it 800.
Cool. Let's do that. So this should work, right? Whoa, it did. And I have not created an infinite loop. My computer is not about to explode, which is good. And we have our first fractal. Cool, right? This is awesome. Hey guys, you're welcome to join if you want.
Just checking in.
If not, yeah, that's cool. So yeah, go ahead.
Counts as a fractal, even though it's just one iteration.
I would argue yes.
Okay.
Anyone have a problem with that? It is not the sort of like Pink Floyd at 2 a.m. kind of fractal kind of thing, you know, but it is a fractal. And at least for me, this was really interesting working through drawing a fractal this way because this actually is a fractal. Now we have two rectangles, so it is a pattern that we haven't really repeated. So I guess it's not really truly fractal-ish yet, but we have the building blocks because we have a function that we pass it a width, and it draws a line down the middle of that width, right? So we can expand on this and make it really cool. Anyone kind of think of a couple other ways we could call this function? Let's say we couldn't do this for some reason. I don't know why. Here that is. You can also do this. Leave. This is a self-calling function, if I'm not mistaken. And you see this. Has anyone ever written in CoffeeScript before? Nobody? No kidding. CoffeeScript is is like JavaScript but with a cleaner syntax, and it does cool stuff too. Because if you just do this kind of stuff, which is really bad, CoffeeScript will wrap this in a self-calling function for you. So if you ever want to have fun, you can write some CoffeeScript and look in your console and see what it compiled to, and you'll see all kinds of really interesting patterns. And I might have broken it. I did break it. What is it mad about?
You still need a semicolon?
I think I need a semicolon, yeah.
I think what you need is grab the function also in parentheses.
Wrap the function in parentheses like this.
Yeah.
Aha.
Not just the brackets since the beginning, since the definition. The whole function and yeah.
And then call it like that?
I think that should.
The width is going to be undefined.
There is no wrong.
Yeah, width is undefined because we actually have to pass in a variable. So this actually doesn't work.
You just throw 800 in.
Yeah.
No, where you invoke it.
Instead of,
Right here, right?
No,
Where you invoke it.
instead
At
of,
the end.
instead of width, call it
like
800.
in the open brackets you have where you don't pass anything, put 800 at the end of the function.
Oh, yeah.
Oh, you mean
Yeah.
you mean here?
Yeah.
Ah. Right. Yeah, cool. Awesome. Yeah, I didn't know you could do that. Yeah. All kinds of horrible things you can do with JavaScript. Cool. So this is a way to do it, but this is kind of weird and obtuse. I didn't know you had to do this. This is why it's never worked for me apparently. So let's go back to draw fractal 800. And it is working. Cool. So far, so good. So we've now drawn 2 rectangles. So how can we make this a little bit cooler? How can, in other words, how can we? Anyone want to take a stab at how we can make this recursive? So you think about it. What we want to do is we want to call this draw fractal method a bunch, and every time we want to give it 1/2 of the original width. So one thing we could do is we could kind of pre-populate an array of widths that were all half of each other. And you know, that would work, and then kind of just like go through and call the function. But there's a little bit more.
Wouldn't that have draw fractal call itself and pass it width over 2? Like that?
Yeah, I think that would do it, right?
Do you want to do like a while with this?
Yes. Okay, yeah. I was going to blow it up, but that's probably bad for the computer. Yeah, so Nene is right. So let's just go down here. Now, probably if I could probably define another function to kind of encapsulate the recursion logic separate from the drawing logic, right? But for now, one good habit as you're, I think is a good habit is, especially if you're doing something is kind of unknown, is kind of write it ugly first, and then you can kind of refactor it to make sense later. If you start to draw, make everything perfect and beautiful and encapsulate all these concerns and all these different methods and functions, it sort of overcomplicates things at first, and you can get caught with weird syntax bugs and not know if it's a syntax error or a logic error. So sometimes it's nice just to write it ugly. So so this right here, this is sort of an interesting thing. What will happen when we still actually have to, call it. What will happen when the browser loads the page right? It's going to go through this script. It's going to assign all these variables. It's going to define itself a function in memory. And then it's going to come to this statement, which it's going to execute. And this statement is going to transfer control to this function, right? And it's going to be inside, and then we're going to be inside that function. And the function is going to be like, okay, draw path. And then it's going to be like, okay, cool, call this function, draw fractal. And it's going to transfer control back, back to this fractal. And so in a lot of ways, where the browser is with the actual code, it's kind of mirrored the fractal drawing. It kind of gets all the way into this little tunnel, and it'll keep calling that function until something tells it to stop. And in this case, it's going to keep going probably forever, right? I don't know if this would error out. We're not going to divide by 0. We're always going to divide something by 2, and you can divide anything, including 0, by 2, right? So that's not going to be so helpful. If you write an infinite loop in your browser, as far as I know, nothing will save you, and your browser will sit there and chew on it while your processor overheats. So how should we do this? Should we do this with a simple if statement? But we just want to catch it, right? So if width is greater than, where should we stop this? 2. Oops. Should do it. This make sense to people? So we're only going to recurse to the point of sanity. And then what will happen is width will be like 2.1. It'll call this, and then it'll go back and be like, oh, width is not 2.1. It will exit. And then control will kind of go back up the stack. And this is interesting because if we had something here like do some function, this wouldn't be called until the browser recurses all the way down to width being greater than 2, which is kind of interesting. I ran into this with my tree fractal because it actually will draw all the left trees before it'll start drawing a right tree because of the way I call the recursion. That makes sense to people. I believe because of the way the call stack works and how the browser, right? Because it's going to go, the first time it's going to call draw fractal 800, and it's going to get 800, blah, blah, blah. And then it's going to be cool, I'm going to draw fractal again. So I'm going to hand control of the program to this new invocation of the fractal program with the width of 400. And then it's going to go, and it's not going to complete the function, right? And so like the big function will hold a little, this is a totally imprecise way of thinking about it. That's how I think about it, right? And then it'll finally be like, okay, cool. I don't have anything to do. So I'm going to give back control to wherever I was in the previous thing, and it'll kind of bubble back up to the top. Then that was pretty coarse.
Does that mean it'll function a lot of times?
Yeah, it'll do it all as many times as you've had recursion.
Yeah, it will. Sure. But it'll do it after passing it. It'll do, what I think will happen is it'll draw the fractal width like 35 times, and then it'll do something 35 times after drawing the fractal. Nope, it won't.
Well, it'll draw.
It'll do it, it'll leave. You can put console.log in there.
I know, that's what I was, yeah, that's what I thought we'd do. Okay, cool. We'll play with that once we, yeah. When I was playing with my trees, I found that I
heard was it'll do all the fractal drawing and then call all the sub-functions.
And it's true for in backward draw.
It'll draw the fractal for one iteration. You call the function for one iteration.
No, I think it keeps going down.
Draw the fractal until it's at the smallest fractal, and then it'll do the smallest something, and then go back and do the second smallest something.
I think we might be agreeing to disagree. I mean, yes, it will. Oh, okay, I see. Yeah, no.
I think that
Recursion. Good thing to slow down.
You should specify like the width.
Good idea. Yeah.
Are you
I'm sorry.
outside now?
Yeah. Well, hold on. So
specify width and narrow.
And
Like
we'll see
pass
it.
width,
Yeah,
I was gonna up here, right? I was just gonna put that up here. Is this what you're saying?
no, pass it to the some other main function.
I would do both.
With
Oh, yeah, that would be good.
Okay, so it's gonna go 800, 400, all the way down to 0, then that 400. Just move on together.
Width over 2.
so let's give this a width.
But that should be the same number unless you make it width over 2.
Yeah, let's do this for sanity and consistency. The test bed. You guys, are we cool for the test bed? All right. Anyone have any money on this? What's gonna happen?
I got cookies.
Oh man. Okay.
Going 2 cookies. It's all in drawing, and then I guess we'll call it something.
What direction is some other function what's gonna come out?
Said in which direction?
We know the draw fractal is gonna go 800, 400, 200, all the way down.
Yeah.
What direction? Once it starts
Ooh.
getting. So what, see,
So you'll see draw fractal width is 800, 400, 200. And then it'll say iron a thing width is 1, 2, 4, all the way back.
I'm
Yeah,
not taking that back.
yeah, I think first,
Yeah.
all the draw fractal is gonna go first, and then I think it's gonna
Yeah.
go at the end.
Yeah, because as soon as it doesn't draw this fractal, it's going to kick control back up to like the next thing in the stack, which at that point happens to be the smallest one, right? Well, let's see. So for do people understand what we're talking about here and why we're doing this? Kind of, sort of. So there's a couple of things. So we're console.log prints things to the browser console, which in JavaScript is very helpful to figure out what the hell's going on. At least for me. So I'm just printing some, you could call these debug statements if you wanted to. And the cool thing about console.log is you can give it all these arguments and it'll actually concatenate them together for you, which is kind of nice with the space. Is that a question?
No.
You just, okay, cool. To play with control during recursion, which actually becomes important as you're drawing fractals, especially if you want to call 2 functions while they're recursing. You want to kind of see what order they come out in. So we're going to see how it handles it. Because what it's not going to do, we don't think, is it's not going to draw the fractal and do some other thing. Bam, 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 bam. And you would think that's what would happen, right? I mean, when I saw this, I was like, oh, cool. It's going to like draw a fractal, and then it's going to do the other thing. It's going to draw another fractal and do the other thing. That's definitely not going to happen. That's what I think.
Why are you passing the half of the width to some other thing?
To some other thing, just to see what it is when it's called, so we can figure out where we are. If it's calling it at the end of the recursion, you know what I mean? And the little like, I think of these things as like nested dolls, kind of like. So this is completely arbitrary, worthless code that.
No, but for me, it has no sense just to pass the width, not width divided by 2. In some other thing.
Yeah, cool. We could do that. I mean, yeah.
Makes sense to me too. Somebody asked for it to be 5x2, which also makes sense.
Yeah, let's do. I'm not that great at math in my head, but I can handle the doubling and halving. So we'll abstract that out to our brains. Okay, cool. Ready, guys? Wow. Okay, cool. So first of all, we made fractals, right? How cool is this? They're not that exciting fractals, but they are fractals, which I think is really cool. We didn't have to go very far, and now we have a little bit of code that will basically do this, like what really could be a large amount of work. If you think if we had a huge canvas, we could draw like thousands of these things, which is super cool. But let's see what happens. Aha! Cookie Man is right. Right, it's going to go.
Oh, because the first one it does is on the smallest.
Yeah, but it didn't go back to 800.
Because if width greater than 2.
Yeah, we have width divided by 2 that way.
Because width is not divided by 2 up here. That is why. So you guys are correct. It makes more sense to do it like this. Yeah, there we go. So I'm logging what the width is in this context up here.
Oh, yeah, because that'll, yeah.
Yeah, because the first logging statement was giving the whole width, and the second logging statement was giving the half width. And this is interesting here. Width is not greater than 2. Does anyone have an idea why this is the case?
Because when it was called, it was 3.125.
Yeah. Everyone see that? Because I'm dividing the width in half up here. Now we could do this totally differently, right? Let's do this with a little bit more sanity and not like divide this argument in 2. When do we give it? We can just do this, right? That seems a little bit more sane because we're dividing it in 2 and we pass it back to the function. So we don't need to divide it in 2 twice. I think that's what we were doing. Yeah, okay, same result, a little bit more sane code.
I think that the first line is you're writing is in the width 800.
Yeah, the initial value is 800. And so that's that. And so that first time we hit this statement, we get this logging statement. And then it's going to call it again, and it's going to pass width divided by 2, which is 400. And so this is like, yo, width is 400 now. The weird thing is I would expect, oh, yeah. So the logging statements didn't change, but the boxes changed. If I do this, we're actually dividing the width by 4 every time. Does that make sense? So you should, when I hit refresh, you should see the box move.
Oh.
No, but they're not. That's weird. And it's drawing the same number of fractals.
Yeah, you know, I think nothing changed. The only thing that changed when you remove divided by 2 there is that the first line that you are drawing is in the 800. It's in the border. We cannot see it. It's in
yeah. Okay, cool. So let's make this maybe even a little bit. Well, we could mess with this a little bit. Yeah, go ahead.
I just want to say the way that you're kind of controlling the recursion depth by looking at the value of the parameter that you're passing in is kind of one way to do it. And the other thing I've seen is essentially you'll pass in 2 parameters. Okay. And the first one is the maximum recursion depth. And as you call recursively, you -1 on depth. And so that gives you a little bit more precise control. Just kind of isolates.
I think it's a great idea. Oh, totally, yeah. So what's your name again? I'm sorry. Michael, yeah. So what Michael was saying is instead of kind of looking at how big the box is that we're drawing, which is sort of kind of a roundabout way to figure out how many times we want to recurse, we're going to tell the function how many boxes we want you to draw. And this is really more a better example of your recursive function, because I think probably in the real world most functions will have some sort of max depth function. If nothing else, you'll ask, the hash, how many levels are you or something like that.
I think both are totally useful in the real world.
Oh, okay. Huh.
That's extra work. Yeah, I was just trying to think, like, what case would you want to actually check the parameter value versus check the recursion depth? Maybe you don't really care what recursion depth you go to. You just want to get some result in that.
Well, it could be like if maybe you were looking for a result and it's like while a thing is nil, recurse, and then if you got a thing, you'd stop. Yeah, so that's also very.
You can also do it statically, like log base 2 with 50. But at the time. I'm sorry, I didn't mean to distract.
No, that's cool. I'm just gonna.
You were empirically stopping recursion
you suggested having max depth, right? What is max depth off the top of your head? You have to like compute it, and I think that would be on base 2.
Oh, if you wanted to ensure that you got down to a certain, yeah.
Cool. So I just factored out this division by 2 stuff into new variables so we can kind of have that in one place. And so let's just re-implement this with this max depth thing. So what we need to do is so max depth is going to be a number, right? Where that's the number of boxes we want to draw. And so every time we draw a box, we want to take 1 off the number of max and go down to 0. Does that seem reasonable? There's a couple ways we could do it. So I probably wouldn't create a new variable here because that doesn't help me think about it that much. So we could just do -1, and then if greater 0. Should work, right?
Yep.
See it.
Max depth, what do you, find max depth?
It did not. It worked hilariously awfully.
I didn't pass the max depth to draw fractal.
Good point. And isn't that crazy that JavaScript does not care? It's like, sure. But that's interesting here. But so the interesting thing here is it did not recurse. So it actually like in Ruby this would blow up because you try to you do something on nil and it would give you a helpful message that you didn't give it max depth. But JavaScript will just happily like do this. So max depth is undefined, I guess, and I guess undefined is greater than 0. That's crazy. Well, we can just type this in here. Yeah, okay, so yeah, false. Okay, that makes sense. Yeah, I mean, but really. Oh, yeah, oh, sorry. Okay. I mean,
What do you expect?
there's some consistency to that insanity, I suppose. This is actually really good, a really good example of why these console.log statements are helpful because JavaScript will do these things that are totally perplexing. If you saw this, you'd be like, oh man, I goofed up. I figured I had a typo in max depth somewhere, right? Because I goofed up my recursion logic, but in reality, I just didn't give it a parameter. So let's try 6. Here we go, cool. We got some boxes. How many boxes do you think we can draw?
10, 5, 9.
Cool.
Took us down to 1, 5, 6, 2.
Yeah. I mean, we can, so we could draw, I don't know how many I can do before I start being really foolish. Yeah, okay, 100 seems reasonable. Might get to 10, 20,000. I might not do it to my computer. I'm going to watch my temperature thing up here. All week I've been doing infinite loops. Okay, we're going to do 1,000. Draw 1,000 boxes. And there are ways we could time this. So maybe we'll time it in a second.
You might want to comment out the console.logs because we're going to slow it down.
Let's definitely not call this. Well, we know when it's done.
It'll give you an error if there's too many.
If the call stack is done.
Yeah, that's the.
Anyone have any idea how many we could do? Okay, so we could have it count to infinity until it blew up.
Yeah. We could probably rescue that exception.
We probably could actually. That'd be fun. I've never rescued an exception in JavaScript, so wow. So I think we just drew 10,000 rectangles.
Change the constant here. Like, instead of multiplying by 1/2, dividing by 2, do like times 0.9.
Use this guy right here. That shouldn't change the thank you. That shouldn't change the number of recursive functions though. It'll just make the boxes tighter.
Yeah, it's fine.
Okay, cool. Yeah, that's cool.
Oh my gosh.
Yeah, wow. Trippy. Yeah, we're getting there. Yeah, that's weird. No, how did that happen?
That's the optical illusion. Wait, what do you do for that?
So if you do, so let's go back to width divided by 2. It starts in the middle because the first I know what's going on. Anyone know what's going on? It was silly me when I refactored. I introduced some unexpected behavior because the first line is actually being drawn over here because I'm passing 800 in, and we're moving to 800 0. So remember, I was doing this, moving to half the width and passing in the max x. So I moved to middle x, but now I'm just moving to whatever I gave it. And since I gave it 800, what's actually happening here is the actually being drawn on top of the border. Yeah, exactly. So, and if we change this to 0.9, to be a little cooler, we see this because the second line is like 90% in.
Does anybody else see like the optical illusion or anything with the projector at the top left corner? It looks like it's like tipping.
You mean here? Oh, totally. Yeah.
It's an optical illusion. Does it look that way on your screen?
Yeah.
A little 3D.
Yeah. So we can do something kind of fun here. One thing we can do is we can colors. Where? So I think we can to a color. Let's try that. And it wants. Anyone know the HTML color? What's red? Can we just? I wonder if we can just do that. Will JavaScript do that? I know you can in CSS, right? Yeah, word. So how can we? When I was playing this before, doesn't it look like something from Indiana Jones in like 1991 or something of this whole? Can we make the color like random?
So try to figure out a way to rotate through the color palette.
Yeah.
In a fractalized fashion, by the same fractal.
Yeah. I mean, so one thing we could do is like I did this. I just pre-populated an array of a bunch of colors and kind of like randomly select one. But
6X is 0. Wait, the 6X is
white, right? Or is that black?
2000. Yeah, it's black. You can go from white to black.
Oh.
Yeah, X and then just do mod. Just do
But it's blue, red, green, so you have to do each one individually.
Yeah, do an array and then RGB values.
RGB would be the way to go.
Oh yeah, totally. Will that take RGB though?
Yeah.
It'll take
At
RGB.
the end of the day, you just can't go from 0, 0, 0, 0, 0, 0 to F by augmenting one.
You kind of do rainbow colors.
As a stream, you should probably, can you do that as a, is there a data type that you can like this?
Yo, it looks like it'll take
Possibly could, it's not
it'll take RGB.
I'm not saying you couldn't do it, I'm just wondering what the fractal color would look like.
So
Because that would basically overflow the green RGB, overflow the green into the blue into the red, which would be cool looking.
what's RGB? So 255. What's red? 242, 40, 40. Let's just see if it. See if that works.
Oh, maybe you have to at least, you have to put that RGB in parentheses if you want to use that.
And it's still not fractal.
And then I'm not sure if you need quotes.
Nice.
But you can interpolate. Can you interpolate in the stream browser?
You just use the concatenated plus, yeah. Yeah, we should definitely get it.
Cool. So how do you guys want to do random colors?
I can't conceive the way that a color can actually be like fractally. We can make it beautiful and Pink Floydish, but
Yeah. Like how could we have every line be like a different kind of random color?
You could just do
oh,
Right.
there's a side overflow for that.
and just plug after the open parens and like make each of those numbers a variable and make it randomly generate that number as an integer between 0 and. No, you don't have to. You can just do it within the function.
Yeah, see silent.
I mean, if you're doing it random,
And then just do RGB times 0.9 for each, for RGB.
Decimals won't work though.
I like that. I mean, that's at least. I don't think that's gonna be very pretty. What's your name? Isn't that gonna go to white very fast?
Well, if it's only 0.9, it'll get towards the end. It'll get to white.
Okay, all right.
Black to white.
So you start at 255.
So do I have to concatenate this stuff like this? Do you think?
Okay, cool. I like this direction.
Plus.
Oh yeah, maybe. Do you actually even need quotes for an RGB value?
Well, the argument takes a string.
Okay.
Yeah, 'cause, yeah.
Then, it must be.
Plus B. What are those numbers? Like 245. Let's just see if it works.
Well, it'll be the same color every time, right?
Yeah, you gotta change the call at line 26.
Line 26, and yeah, cool. Okay, cool.
0.9.
So that worked. Should we just reassign?
0.9.
Yep, thank you.
That's Ruby where that is.
JavaScript will just, yeah. Well, and what's the top RGB color code? 255. So why don't we start at 255 and I wonder what'll happen. It'll be trippy. Ready? Wow. Or not. Whoa. Well, oh, can you guys see that? What happened to the? Oh, they're all white. Do you see that? See how that line is fading up to the top there?
Maybe because it can't be decimals.
Oh.
No, well, because it worked. I mean, the string concatenation thing worked, but maybe because they can't be decimals.
We should round it to
Can we just?
Sorry,
Can I-
Parsons,
instead of 255, sorry, 0.
it's getting 0 times 0.9 is also good.
Is that the parsant?
I think so.
With an E.
Whoop. So for you Vim users, I'm sure watching me do this is painful, but
You see it?
I'm learning. Yeah.
do you save without?
Command S. I just have it so deeply wired, man.
That's wacky, but awesome.
Yeah, I know. Yeah.
What's 250 times?
That's white, right?
That's,
If they're always at the same number, it's going to be a shape.
Oh.
Thank you.
It just changed like the first one.
Oh no, oh no.
right.
Something horrible is happening. Okay.
But that's kind of a color. Line.
Whoops.
They're all equal.
Whoops. There we go. Okay. So that produced some sort of horrible loop thing. So they're all equal. So what do you think we should just do? Whoop.
I guess they all the same color. Just different
Well,
shades.
that's 24 bits, so we could go from 0 to whatever max. We could do.
Oh.
idea.
There they are.
That's a little cooler.
Purple to reddish.
And then to black really fast.
And maybe the more different the three values are for RGB, the more we'll notice.
Like 0.92, 0.91.
What we're is parsing is that just taking the 0 off? So like 1.5 is 1. Does anyone know off the top of the head what parsing is doing actually?
Oh.
I think so.
Wow, you can. Oh my goodness. Okay, whatever. That's too. Cool. Well, you guys want to keep playing with these colors? You want to draw boxes, or what do you want to do? Let's draw some. We can draw some boxes. We can do this kind of the same stuff with boxes, or go to vote.
Let's do boxes.
Cool. Boxes. Okay, sweet. So let's save this. And I'm going to make a new squares. And you'll be happy. And, you know, actually I can do rectangles. Two. Needs more. Whoa. Monitor is the overhead is the only source of light here, so I have to keep. Cool. So let's get rid of this stuff. Start clean. And then, whoop. Squares 2. Cool. So we have a square, and it's drawing a box. So I just copied the file and deleted all the other stuff. Squares are kind of interesting. They are slightly, for me, it was slightly more tricky than rectangles because you can't really just divide foolishly. Does anyone want to give this a shot about how we should? I'm going to say instead of maybe instead of instead of drawing this first box, we'll use our recursive function. That's kind of the first level of fractal. So all right, what do we need to know here? We'll follow the same pattern, but instead of simply moving, so we're going to have to do two things. We're going to have to move, right? And instead of calling line 2, we're going to call rectangle. Does that make sense? Stab at the first thing we got to do here. I can go cheat and look at what I did earlier, but.
What is the goal? Draw rectangles like vertical rectangles?
Ah, good question. I put a draw button on this for fun. That's what we want to do.
Oh, that's cool.
Yeah, I know, right? We're inching towards Pink Floyd territory here. So that's what we want to do, right? And so that's why I took off that border drawing function, because we don't really need it, because the border is kind of our biggest square. I just drew the border on the other one just for like a context thing. So what we want to do here is we want to draw a box, right? And then we want to move the cursor to the next corner and draw a smaller box. Make sense to everybody? So we know we're going to have to call cxt.rect, right? cpx.stroke. And we have to do this begin path business function call. So it seems like our recursive function is now going to take at least 4 arguments, right? The initial x value, initial y value, width, so that corresponds to the x, and length, I guess.
Now, these are squared, so these are width and length the same.
Width and length will be the same. That's right. And that's a very good point. But I would say at this point, let's keep them different, and then we can refactor that a little bit later to make it simple. I think you're right. But maybe we wanted to shift this function to draw rectangles as well as squares. Yeah.
Length is the
Width, and that's probably a better width and length are kind of the same concept, aren't they? So that's a little bit better. And so how many words? One. Well, I'm just going to use my mouse. Idiot. So this should, if we this should draw our box, right? Make sense? Squares, cool. And let's make sure, because I didn't even see that show up. We commented out, we got nothing. Put it back in. Cool. Okay. So we have 1. Can you guys see
the border before?
Exactly, but instead of doing it with this like horrible iterative code, one thing I'll mention now, actually, before we start playing this, I kind of wanted to mention, you guys probably know this, but variable scoping in JavaScript is kind of scary. And the two kind of things to remember is you want to put the var keyword in front of everything, because if you don't do this, JavaScript creates a global variable called canvas, which I believe is available everywhere in your entire application. which is horrible. So rule number one, and rule number two is, at least I've been trying to follow, is that variables are scoped based on kind of the top closure that they're in, right? So with this canvas and CTX variable, you notice we're not passing CTX into this function, but I can still call it. This makes intuitive sense, right? But later on down, let's say we were declaring a variable that was like var counter equals 0, right? And then I was doing something like if counter greater than 0. This would be a really, really horrible thing to do. Can anyone tell me why? You guys seem to know JavaScript better than I do, so I'm sure you know. The reason is that this counter is all the functions I can put in this file. Counter is always going to point to this one counter entity that's all the way at the top. It's not going to reset itself because I'm inside of a function. So the standard thing in JavaScript is to wrap most or everything you do in a function, because that makes sure your variable definitions are closed in that closure scope. And if you write CoffeeScript, it puts everything you do inside one of those self-calling anonymous functions that we wrote earlier with the parentheses. So I think it's probably safe to say that it's a code smell in JavaScript to declare a bunch of variables not inside of the scope of a function. So if I was going to rewrite this, I would make a function that's like get canvas that returns a CTX, and I'd pass CTX into each one of these functions to make sure I knew what CTX thing I was talking about. Does that make sense? So, anyway, but for this, it's fun. We don't need to worry about that. Okay, cool. So we've got one going on. What do we need to do?
Refactor the variables that we passed in and call the function again?
Okay, cool. So let's just do the simple. Let's do width. The initial x is 0, right? Width, if width is greater than 2, draw fractal. And how do we need to modify these variables? Any guess?
Something about reducing x and changing x and y by the same amount we reduce the width. Make the x and y number over the same number that we reduce the width and height.
Yeah, that makes sense.
Okay, cool. So what do I pass? Let's take it a step at a time. What should the new x be?
Would be the initial x plus an amount.
10? Okay, cool.
Or would it be minus?
We can put that maybe in a variable and we can change it in one place, because it's going to be the same amount that we're going to add to x, y, and width. And
Yeah, let's do that. New x. Okay, cool. Yeah, let's do that straight up here. So initial x plus 10. Cool. And this makes sense, right? Because the initial x and y are 0, 0. And we need to remember, we need to move in and we actually, this is what I first got confused about, this like 0, 0, like mind bending stuff. We're actually just moving into the graph. So that should be good. And then we need to do new width and new height. So what do we want these to be?
Same, but minus 10? With minus 10?
I think so, right? With minus 10.
20.
Oh, yeah, both sides.
Yeah. I don't know if this will work or not. I'm just kind of curious to see. So I'm good. Do I want to do this inside this recursive function? Let's do it outside. No, let's just leave it in there. Why not? Okay, everybody okay with this so far? Nice. Kinda. It's pretty cool. We made some kind of trippy, like hallucinogenic boxes. That's pretty cool. Is this actually a fractal? I guess it's a fractal. Yeah, that's pretty cool. Is definitely, can't look at it very well. Yeah, geez, huh?
Well, it's like,
So if you guys are ever in a position where you're working for a children's science museum and you need to come up with, visual, what are they called? You know now how to do it with the recursive functions in JavaScript. So this is cool. How can we, let's take it a step further and let's make them get progressively smaller though. Does that sound cool? This is awesome. This is way simpler than the first time I tried it. But each box is the same offset as the parent box. Can we make the offsets be logarithmic would be or exponential would be the word? Yeah. How do we do that? I'm genuinely curious because I mean I have the solution to GitHub. I can just look. But I want to. So by like maybe 0.1, 1.1 probably, right? Because we want a bigger number than we started with. Not a. We can't multiply the initial x. If we start at 0, 0, we could cheat. Start at like 1, 1. But multiplying 1 times 1.1 will give us 1.1. That might work.
Well, you can multiply now after add 10. The first time is going to be 0, but next time is going to be 10 times what you're going to multiply.
Sure, yeah, that, maybe it is easier to just start at 1 so that the one thing do that.
Let's pretend we can't for right now, though.
Okay.
Yeah, but I know what you, yeah. And then width is a value when we start. We know width is defined, so we can multiply, and there, right? But we want to do it maybe time.
Although that won't be the exact same amount. I think it won't be squared like that.
Yeah. Let's see. That's cool. Sweet. Now that actually is a kind of a cool distorted thing. Okay, cool. So looks like we got the these are offsets are getting bigger, not smaller though.
Because the X and Y are changing at the same rate as the width and height. So it's not.
Yeah, that's well. I was looking even with
Oh yeah.
even this gap is getting the gaps are getting bigger, which makes sense because I'm adding and multiplying.
Yeah.
But we want the gaps to get smaller, so we want the first gap to be the biggest, right? So how can we do that? We can add 10, and then maybe we can multiply it. Let's just try. Ah, that's cool. Okay, so we got the gap going. It's a little smaller than I kind of wanted, but that's cool. Yeah. So what are we doing? So this is where console.log is really helpful because we can just log these parameters and we can look and see what things are actually being set at. Okay, cool. 00800, 800 makes sense because that's our initial call. And then we get 99. Okay, so it's going 99. And then 640 to 640. And one question I have immediately is, are these actually the height and width, or are these the X and Y's of the endpoint? They're the X and Y's of the endpoint, huh? I kind of think you might be correct, but I can't remember. So let's look at the docs. The width of the, no, they're height and width in pixels. Yeah. What I was wondering is like maybe it's the X and the Y coordinates of the other, like, but it's not.
You have to subtract that by the same amount. Like with minus 20 times 0.9 would probably lead to. Oh, but does that mean it'll look the same as it did before?
Maybe. That's probably not going to work. Better. Let's look and see what's going on here. 702 and 702. So the problem is that we're taking 92 off the width in pixels. So we can look at this and we can see that this width is too small.
Yeah, we should subtract the new X from the new width. New X times 2 from the new width.
Do we still need to multiply it if we do that, or can we just do that? Let's just give that a shot without the multiplying.
Well, we should multiply by 2, right?
Wow, that's cool. 99791.
We need to subtract 2 times the new X.
Well, the one is it? Well, notice how these are both still adding up to 800, and so the rectangles are all ending. Because this is drawing a rectangle from here. See that rectangle is going all the way to the edge.
Yeah, because our new width is too much. It means we need to subtract 2 times new X.
I don't need parentheses for that, right? Better. Where's that first one going? Okay. There's still something funny going on.
What's our goal? Keep flipping?
Well, the goal is something totally arbitrary that I decided is to recreate what I did for fun, which is this. Bam.
I think we already have something like that.
Yeah, but we're like figuring out how to do it from scratch. I mean, I could look at GitHub. We're on the right path. This is exactly what I did to figure it out because it's not very intuitive, at least for me. I can't really hold this in my brain and just like figure out what it should be.
So it seems like for your thing, you're decreasing the distance but starting higher. But we're only adding 10 pixels, so maybe we want to add like 40.
Well,
That's one start.
so what's happening is the thing that you're adding, the scalar, is overwhelming the multiplier in the small case.
Yeah.
You're talking about these.
Like in this, the case where,
Plus 10.
oh, so now you got it.
Well, what is the,
I think about it. So
Well,
so okay, so 0, 0, 800, and then we added 10 times 0.9, so we got 9, and then we subtracted 18, and then we got this guy, which actually looks right, or looks kind of close to right. I mean, we probably should be dealing with bigger numbers, but we can worry about that once we get the pattern down. And then the third one, we're starting at 1717. So that's right here. And then,
What's the one that kind of goes up the opposite directions?
yeah, I don't know. I don't know what guy that is. That's sort of one of the, I wish I could click on it.
Minus, you've got at the very bottom, you've got a minus 68, minus 68.
There it is, yeah.
So that's because.
Probably because I'm doing the doing this stuff in here, right? What if I?
So you're doing a -2 times the new. As the new lines get bigger and bigger, you're minusing.
Yeah, it's this. Yeah, it's this, right? Because yeah, as these new x's and y's are getting bigger, we're taking increasing chunks off of, and what's happening is that we're drawing, the square has now flipped on itself because we have a negative width and height with which Canvas is happily like drawing over here, or you know what I mean, like that other box is up by the speaker. So we need to figure out a way to remove we can't multiply new x and new y, right? And if we just take off, if we just do this, we decided the first one is hitting the edge, and so it's not and I think it's actually
Is it because if we do 2 times new x, we're computing the x distance, but then we actually have to compute the x, y somehow, but since they're the same number, it would be the same.
I remember.
Or no, it's like from the 0, 0 point to the new point. Is that the distance between those two is the number that we actually need to know to compute the new square?
Yeah, well, to compute the new square, we need to know these coordinates, but then we also need to know this width and length, or this width in pixels. And we are still making in boxes that what do we want?
Is it initial x minus new?
Interesting. The multiplication is intuitively attractive because that's kind of what we want, but it I'm hanging actually. So I think I'm going to cheat because we're right and look at my solution. So this is what I wrote. Where's that get Canvas? Anyway, so I'm passing in an offset, and I know that the x and the y coordinates are always going to be the same. So offset, offset, length, length. You see I'm doing some color stuff here with the array. And then calculate a variable called shift, which is really just the length times 0.05, which is just arbitrary. And then I'm adding the shift to the offset. And then for the length, I'm subtracting double the shift. So Nene was like really close. But to make this work, we have to take the multiplication out. Because really, if you think about it, what we need to do is we just need to calculate the shift value for the new box, because we know that for each box we draw, right? If I could draw this. So each box we draw, this delta is equal to that delta, right? And then so on and so forth. So all we really need to calculate when we recurse is a new shift. And then we simply need to basically add the shift here and then subtract it here. And then to subtract it, we need to do double. Does that make sense?
Yes.
Cool, sweet.
For tables, can you throw in a context.rotate?
Yeah, let's open the file that actually works, and I don't know. Okay, so here it is actually working. And I have it over here on this tab, and you can see I'm doing the poor man's like color thing by just I'm just pulling a random array element off that, calculating a shift, and then just doing this. And this keeps, by doing this solves the problem with the multiplication being relative to the new x and y, right? Because it's actually relative to the shift value, not the new x and y. And let's do a context.rotate. You know, we could probably do this with like a scale function, but I'm sure there's like actually like one line that would just do this, but yeah, I mean, there's also beautiful fractals on Stack Overflow we can copy and paste if that's what we were going for. So it looks like ctx.rotate gives it a rotation angle in radians. Thank you, math. So where's my draw fractal function? So should just throw it here before the and what it's 2 pi. So
Just do like whatever degree, like 3 degrees times math.pi.
you know, I'm not sure if I have math. I haven't ran that before. It's true. But math, that just looks so. Whoa, word. That's cool. It looked like it rotates the. That's really weird. It's like rotating it off the screen. I thought it rotated in place.
That's wild.
Yeah. And it's not changing colors every time either, but that is super cool. Why? That's really weird. The rotate function is really bizarre. Let's see what other cool, weird functions we could throw at it.
There's a transform one that looked kind of cool.
Yeah, what does it do?
There's yeah, you get really complicated with a matrix transform.
Yeah, you know, I think I was looking at, if you look at the like Mandelbrot fractal code, if you Google like Mandelbrot fractal HTML5, you'll see all this kind of stuff that's difficult for me to get my head around. So it takes 6. Oh my goodness. So let's do this. Launch. Anyone have any idea what this is going to do? Made a big yellow box. That's not that exciting. That rotate thing is super cool. It's really weird how it it seems to move the center of it. It's rotating off that origin point is what it is, right? What's going on?
So you want to like rotate and shift.
Yeah, totally. Get a little bit too involved, but yeah, we have to rotate it and then shift it back. Then
Translate.
after rotate.
Yeah, make the X, Y coordinate. So we could do like
Offset is our X and our Y.
yeah, that's probably. Let's do that.
Why not just go with that?
Oh.
Yeah. Whoa. Yeah. Might be a little big. Point. That's weird. It's still rotating, but
Maybe you're good for X, but change for Y. Since you're doing times 0.1 for X and Y. Maybe
You know what? It might be because there's like the way you've got a global. So you're setting every time context.
yeah, I'm just grabbing it in the.
we can try offset times 0.01 there.
There. Put it away.
Well, just trying to keep it from going off the screen.
I think it's these are all super cool. Cool. So I want to show you. I want to wrap up here. These are super fun and cool. You guys should go home and play with some of these. And I want to show you what I was working on that I don't have working. I figured out my problem. I want to draw tree fractals, right? Thanks for Gabe for giving me these fractal ideas. Tree fractal is like pretty simple. It's like you draw like a tree, and then you draw a tree, right? And a tree. So on and so forth. And it's kind of fun. I don't have it working, and so I take pull requests so you guys can fix it. So it's you see I didn't kind of refactor the code. I'm drawing a box, and then let's look at this here. Oh, it's like way more broken than it was before. Whoops.
It's sort of fractalized.
Yeah, it was actually even in better shape before I started hacking on it. Better. Get oh, Saturday, cool.
You did a reset.
Yeah, I know. I realized I
Just
did.
do GCO dot. All the stuff is saved.
Do what?
GCO for get checkout space dot. And then what's going on now?
My branches is dirty, I think.
Sorry, I didn't notice that it was dirty.
That's cool.
The GCO dot should
Check out head.
Yeah. Sorry, yeah. Is it check out head 2?
Just get ahead to get us back to the happy place. Get logged. That's it, right? Okay.
No, I want to go back one more. So is it
Yeah, you have the right idea.
that right?
Yeah.
Yeah. Okay. Cool. Oh.
That's not a thing.
Let's go back to master. Yeah. Oh, cool. That's what I wanted to show you. Yeah. Okay. Cool. So
Looks like the right direction.
it's close. It's close. So begin path. Oh yeah, and it's cool, and you can see the log here too. So the interesting thing here is my recursive function calls this twice, which is why I brought that thing up at the beginning. How does it transfer the control?
So are you calling from inside? You're calling the sync. You're calling it twice. One to the left, tree, one to the right.
Yeah. So what I do is I move to the bottom and I draw a line, and then I draw a line. Then I move back to the branch, and then I recurve the nodes of the branch.
So this will execute the same way. Remember we did the large statements where like you took all the frame stack frame going up.
Yeah.
And it came back down, and as it was coming back into the logs, but this way
It'll do all the left. Yeah, it's like a that first.
Yeah, totally. It'll do it. And here's the problem with my code. If you see, the first ones are doing fine, and then this is the first recursive call to do it, and that's cool. It draws the left one, but yeah, it draws the left trees, but this one here is totally borked because my left line is simply dividing start X and Y by 2 and 4. So it's like drawing it all the way back over there. So what I need to do, I think, is just kind of like how the square thing was relative to a shift. I need to basically change the relative frame every time I recurse. And the recursive function shouldn't be relative to the canvas size. It should be relative to like a little box. And I just didn't do it. But these are really cool. And it's like, you can have a lot of fun. So
is Canvas performance enough to do for like games?
I don't know. I was going to is Google smart enough to? Yes, it is.
You gotta play with 3JS and WebGL. I haven't. It's all.
Yeah. Well, so I mean, there's what this says WebGL is not Canvas.
WebGL renders to Canvas. If you just Google 3JS demos, there's outrageous stuff. Sure. Internet or something.
Yeah. Thanks, Noisebridge. Holy shit.
Some of them are more demo-ish, and some of them are more mind-blowing-ish.
Okay, that's not helping.
That's so cool.
So do you recognize the pattern on the inside? It's a I don't know if there's like a common name for that. Yes, it's like the maze pattern.
I actually see, I know what it's in this book.
Oh, you mean it's like the same maze as like all these other maze
You
patterns?
generate it with like 16 characters of Unix commands.
Oh wow, we have look at that.
That's it. You got the maze on the book, but there's a command. It's 16
Wow.
commands you put in your console. So this stuff's got free record.
What?
That's the source, 370 lines.
Wow.
Guy, you remember me and Google for like shell maze one-liner?
So what?
Maze one-liner.
I want to quit my job and live this whole thing.
Sure. That one.
Just gonna break my.
No, that's the basic version. You gotta scroll down for the answer. It won't break it.
Oh yeah, of course it's basic. Yeah. This looks like bash.
40 characters. Okay.
Shortest bash, 40 characters.
Oh, a shorter one for CSH. You're running CSH.
No, it's 53 characters.
Fair enough. Okay, so you're using like a different font. Shoot.
It's still kind of cool.
You know what I mean? It should look like beautiful.
Maybe I need to do the Z shell one. Stop it.
You decrease the width of the terminal.
Or do you have any other terminals installed that?
And oh my Z is like, I don't really have anything going on with it.
You don't have like iTerm or something?
Oh, I am using this is iTerm. Go away. Maybe I can just do it
Yeah,
in
terminal app?
yep, somewhere in here.
How is iTerm better?
iTerm 2 is way better.
Yeah, this is iTerm too. Yeah. This is not. Oh,
See, yeah. Okay, so that is different than yours. Why is it different? It looks like a maze.
It's very similar.
wow, this is making lots of maze. Cool. Well, I should go. I gotta get the train, guys. Thanks.
That was awesome, Brad.
Yeah, thanks. Whoa. Yeah. Are you gonna do that this weekend? I know. I wanted to do that last year, and I just never got around to it. I'd be happy to.